Good afternoon. I welcome you all to the afternoon session of day 2. This session will be continued by Mr. Akshay Arora, Senior Consultant, ThoughtWorks, on the topic of Unity. I request Mr. Akshay Arora to take over the session.
Thank you so much, ma'am, and good afternoon, everyone. I hope you had, all of you had your lunch. So I'll just quickly share. Uh, is my screen visible to all?
Yes, sir. It is visible, sir.
Okay, okay, thank you. Let me just start. Okay, so this session will we mostly cover, like in the last session we will get to know about Unity, we install Unity, and we get started with Unity. Now how to work in Unity, how to make actually make content, we'll understand what are the basic things that we know, that we should know in Unity, all the basic components, basic systems, and all of these things. So what are we covering in this sessions is the core of Unity. Actually, we had this part in the last session of components and transforms and all, and we'll understand more about game objects. Then we understand about the parent-child systems. What are they? Then we understand the concepts of prefabs, and then we will get to know about scripting, how we can script, we write code in Unity, how can we attach the scripts, how can we link our code to the components, to the actual game objects and all. Then we know about Unity physics, what are the various kind of physics and systems are available in Unity. Then we'll get to know about how to make UI in Unity, some 3D stuff like materials and shaders, what are they, and then we'll make a small game, very small game. Okay, so start with our first thing, the core of Unity. Core of Unity, we already covered that how Unity works, scenes, what are the, how to navigate in scenes, what are the game view, inspector view, gizmos. I'll let you know in this one. Like the whole the things that you see, the arrows and all, these are the gizmos only. Now let's see what are the game objects. So I'll basically in this one I'll basically focus on the actual live demonstration rather than just theoretical part. To this will let you better understand how things work actually, like the practical things, how practically it works. So let me just recreate the project that will help you to revisit the thing. So I opened my Unity Hub. I have all the projects. Now I need to create one project. So I will just create new, and same thing. I will change, I will write a name, Unity session, sorry, and the location, and just create. Will take 1 or 2 minutes. Okay, so as we know, this is screen now. We have the scene view, we have the scene, the game view, inspector. We have a test runner. This will help us to run all the tests. In coming sessions, we will see about all of this. And we have project, and we have a console. So this in last session we didn't cover this console. Console is basically where all your logs and all will come. The console window basically in any editor you will see. Now let's understand what are the game objects and what are the different things. Like, let's understand in the detail. So as we understand by now that game objects are combination of components. Components basically define the behavior of the game object. What type of, for example, now this component is a camera. Now the behavior of this game object is to render things, like to visualize it. The other component is the audio listener, so it will listen all the audios from your whoever emits the audio. It will listen. So it is kind of, it has eye and it has ears. If you visualize it uh, with a real world scenario. Now this game object has a behavior of light because a component with light is linked with this. Okay, so it is components behind behavior, and game object will morph according to the components. And we have transforms. As we discussed in the last session, transform are the core component of every game object. Even if we create an empty game object, we will have this transform. It's a heart of the game object. You will let Unity know that you will need to know. You need to tell Unity that you need to place your game object at this where, in which direction, and how much, how large. Okay, then we have other things called tags. Tag is basically helps you like it's a unique name, you will see, for you can helps to identify game objects for scripting purposes. For example, uh, I am a game object and my tag is a software developer. So script can easily tag me with my basic role, I would say, or some identity. So for example, if this has a tag main camera, then everyone can understand, script can understand that a main camera, a tag with main camera associated with this guy, right? So if I have two things, like for example, two players, so we will just tag them as players. And for example, if two enemies, so what we can do is we can just add a tag. This window will pop up, and then we click on add, then we can enemy and save. Now we can again go back, select both the objects, go to the tag and select enemy. So now my script will know, basically it's used for scripting purposes. My script will know that with tag with enemy are these objects, and tag with players are these objects, and tag with camera is this object. Okay, I hope you got the concept of tag. Layer is basically a kind of tag only, but it is kind like it's a separate concept to add a layers over that. For it basically used for physics and rendering things. It is we don't need to go deeper about it. Then we have static and all. It is also used for performance things. These are all the performance, like this is advanced thing. We don't need to go deeper here. So let me just remove all of this. Okay. Then let's understand the concept of object parenting. So in Unity, objects follows a hierarchy system. Using this system, game objects can become parents of other game objects, right? When a game object has a parent, it will perform all its transform changes with respect to other game objects instead of the whole world. I'll with the example. For example, this is my one game object, and I will create a other object. Okay, so let's say this one. Okay, let's not create a game object. Let's create two cubes. Let's create the empty one instead. Create cubes. Let's change the x value. One is here, and the one is here. So you can see now that my game object is moving with the reference of 000 world. Okay, and if I create one other cube and it has no parent, this cube has no parent, and this cube 1 has no parent. Okay, I'll just zoom in a bit and let me know if you are able to zoom that. Able to see? Is it any better? I tried to zoom in, but there's no any tool applicable for basically Unity to zoom it. So okay, so if we this cube 1 is also moving with respect to the 000 only. If I move here, so it will from 000 from this point to this point, it moved 5.78 meters. Okay, suppose I change it, I delete it, and I make a child of this cube, the sphere, for example, right? So the 000 reference is not here for this sphere. Okay, now it will take all of its transform value, all of its transform changes with respect to its parent, not to the whole world. So if I move this sphere for 5 centimeter to left, it will take the reference from its parent, not the actual, not from the game world. And if I move the cube upwards and downwards, the sphere will also move because it's in child. If the parent moves, the child will move, but it's not vice versa. If the child moves, it's independent. It is not rated. And if the parent rotates, so see the child rotates around him, right? So this is a object parenting system. This is a hierarchy system. So a child will have all the references from its parent, not from the game origin of the of your grid, right? Let's try to understand more with let's create a will we create? Let's create a chair with this objects and this object parenting concept. Okay, and let's create a chair with all the cubes and cylinders and all. So we'll create a empty object. Let's rename it to chair. Okay, we have the transform value to 000. Let's create a child, 3D object. Let's create a cube. And this cube will not be a square. It should be something like this. Let's say, okay. And then let's call it a base. Okay. We have our base ready. Our base is too high. Let's squeeze this down. Let's reduce it. So it's kind of a rectangle base. Then we have the 4 legs of our this thing, our base, right? So let's create cylinders out of that, and sorry, let's create a cylinder here. So the now it is related to the chair. It's 111 to the chair, not from this base. If I drag it and inside it, see it changes. If I change to 111, see the size changed, right? So it is now it is taking its whole transform values from the from its parent base. Okay, let me just move it and also squeeze it down to look like a leg. These are the various tools that we can navigate and all that we had a discussion in the first session. Very good. Let's okay. Now it's just happening. Now let's move this to one but you will see the game's view in the game window, right? But pardon my artistic skills. Leg 1, leg 2, duplicate this and this reposition this leg 2 to this point, and then we'll make a other leg. This point, and other one is this point. Okay, this is how you create a game object, move it, like to make real shapes. Okay, this is just a basic. So we have created a base. Now we need to give this chair a back support. Okay, what we can do is we can make a cube and now and reposition it somewhat here. We can look from other angle. How is it looking? No, it is not inclined with. Let me scale it up to match the edge, and it is looking very much bigger. So let's squeeze it up and let's move it this tool to the edge. Okay, now I think it's looking like a chair, right? So that is how you use parent and child. Now if I have to rotate this chair, I don't need to rotate all of my part, all of my base and this legs and this cushioning system. What I need to do is I just need to grab the parent, the chair, a whole chair object, and then I can just move the y through its y axis. See, the whole object will move. Okay, so that is a very core concept of working in Unity, the object and the parent-child relationship. That will help you in working in Unity. Okay, this is how we do it. Okay, let's uh, keep the chair with us. And now let's understand other concept of prefab. So sometimes we need multiple copies of same objects, right? So prefabs are in a way a copy of a game object that can be duplicated and put into a scene. And also prefabs can be used to dynamically generate. Sometimes we don't know when to create a chair. Okay, we don't know with the help of, like in the actual application, for example, like if you are if you see something, for example, if I tap on my on a button, a chair should come, or on a tap of a sofa button, sofa will come. So what on that kind of scenes where you need to dynamically generate your game objects instead of having it in the scene, we generally use prefabs. How we can use it? Like what are the prefabs and how we create a prefab? Let's understand this. Okay. Now this is a chair. So prefab can be very easily be generated. Just what we need to do is we need to hold the game object from our scene hierarchy and just drag it over the project window in the asset any folder in the project window. Now you will see a change that it becomes like it has the icon, the blue colored icon, and the extension that we got it dot prefab. Okay. Other example of a prefab is that, for example, if you are firing a gun in a game, then you don't know how much bullets you need to fire. It will be from the user's input, right? If I tap like 5 bullets, 4 bullets, we don't know. So we need to dynamically generate it at the runtime, right? So that's why we use prefab to basically main purpose is to dynamically generate the objects at the runtime. Now we have multiple instances. For example, the other main use of prefabs is we can make a instance of that. For example, I'm not happy with this chair. I need my back support a little bit larger. Okay, we can do this. So my one guy want a back support a bit medium size, and I will create another prefab, which is basically, let me move it to separate, and I want it my back support to be extended. I can easily do that, so that I can use my same chair to, I don't need to recreate it every time. I can just use it dynamically, change it values and things like that. So I can have multiple instances of that prefab, and our main prefab will remain same. If I again drop the main prefab, it will not make any change until unless we apply the changes. How do we apply the changes? So if we look into this inspector window, as I said, like to modify any of the properties or something, we need to go to the inspector window, and then to modify its component. So in case of prefab, we need to go to the inspector window, and you will see overrides. So it will show you what all changes have you done. So what we done is, in the to the chair prefab in this scene, what we did is, in the cube game object, we changed the transform. Earlier the transform is this, now it's sorry, its y value is this, the y scale is this, now it's this. So it will show you everything that you change this and it change it. Do you want to apply or not? If you don't apply it, it will not apply to the original prefab. It will only apply to the prefab, which is only the scope of this prefab is within this scene only. Okay, so these are the basic concepts of prefab. If you have any question, please ask regarding this prefab. No questions? Okay, let's move on to our next thing, that nested prefab. So as we know, like the nested thing is a prefab within prefab. Sometimes we want to create, for example, a room which is already a prefab, and our chair is a prefab. So we can use, we can just integrate our chair prefab into a room prefab. So it is also possible. Then we have prefab variants. What's the difference between variants and instances? Instances basically are the scope of instances, like these are the instances of that the prefab. So the scope of these instances is within this scene. But if you can also create a variant of this prefab. For example, right now the color of chair is red. We can create a other prefab variant with this chair with a red color, or it can do some other operation. It can move, or it has wheels or something like that. It basically works like a concept of oops, like inheritance. You have the base class, you have the base chair, and you have multiple subclasses that will derive from that chair. It is exactly same, the prefab variant part. Okay, so let's move on. The next thing is scripting. Now we want to add some functionality. This is completely raw. It's doing nothing, right? What we want to do is to let's rotate this chair for around, like with first of all, we'll try some automatic rotation. Then we will see how can we rotate it using our like arrow keys. Okay. So for that, we need to create a script first. So what we need to do is, let's first create a folder. No, sorry. Scripts. So open this scripts folder, right click here and create C# script. So all the coding that Unity supports should be in C#. only. Okay, let's create a C# script. Let's call him rotate. Click enter. I will see it will compile. Editor will compile. As soon as it stops this loading bar, it compiles. So you can see the script for a rotate.cs. Okay, let's double click on that. See, my ID was JetBrains Rider. So as soon as I open this script, it will launch the rider. That is what I was speaking about integration. That is how Unity integrates rider and connects, and it's preparing all of these syncing projects, and all of this will be done automatically. You don't need to care about anything. Give me 1 minute. Let me have some water. Okay, great. I think it's loaded. So what do we have in a basic script in Unity? We have some imports which have some classes that Unity have by default. Then we have the name of our class rotate, which derives from a mono behavior. So mono behavior is a class which has some functions, event functions. We will know about it in few minutes. Every class in Unity derives from mono behavior by default. You can modify it based on your needs. You can make your static classes and like things like that based on your need. But every default class derives from the mono behavior, and it has a some events like start and update. These are called life cycle events. So let's understand what are these events in detail. So we have these functions. So by default, Unity provides a start, and there should be have update. So let's also understand the life cycle flowchart of Unity. First of all, we have awake. Awake basically is the first touch point of every script. Then we have on enable, then reset and start. Start basically is only ever called once for a given script. As soon as you start your execution, the contents in this function will be called only once. Okay. Then we have some functions which basically called for each frame. Okay, these functions are these are some physics functions. We don't need to look into the deeper part. These are some input events. We'll talk about it later. And we have update. Yeah, this is the game logic and all. So we have update function which called each frame, right? It will like for example, if your FPS is like frames per second is 60, so it will call 60 times per frame. Okay, that's how update is calling. So update is you can see the documentation here as well. Like update is called once per frame, and the start is called before first frame update. It will call once, it will call every time. So you will need update for getting your input or moving your player. Like you need to move your player each frame, right? Like a sequence of events. Otherwise, it will look like a jerk, like a jerky movement. So that is why in game development you will need update function. These are the two functions by default Unity provide. You can delete or add other functions that are provided here based on your particular use. So let's see in action how can we attach this script, and also we will understand logs. What are the logs? So Unity provides a class called debug. Is the font visible to everyone, or I can just increase it? There should be a presentation view. Okay.
Sir, it is visible, sir.
Is it good now? Okay. So
Yes, sir, it is better.
yeah. So start with like there's a base class, like not the base class. Unity provides a class called debug, which has you can see here Unity engine.debug, which has the basic debugging features like logs and if you want to print log warning or in a particular format or log error and things like that, you can do it in this. Now what log takes is a message in string. So let's see, let's debug the start called. Okay. And let's see other things, for example, like error. If you want to print some error in case, and let's print log error, and it's the same string message that update function is called. Okay, as soon as you hit control space, command S or control and S windows, it will save your script and it will start compiling to. Okay, so it is like as soon as you open Unity, it will say compiling scripts. Let it compile. Just for the first time, it will take some time. I don't know why it's taking so much time right now. It not take that much time. It just convert. So for the preview of the script, you can see by clicking on that you wrote debug.log start is called and debug is attached. Now we see this how to link this script to this. Very simple. You just need to drag this rotate and add this like a component. Okay, this is you can call a user defined component that Unity does not provide, but you are creating a behavior of it. Okay, so it is attached. So as soon as you play it, the first thing that will run is the start function. Okay, because it will run before the first frame. As soon as you hit play, the start is called, and then every like 60 times per second or whatever the FPS is, it will call each frame. So let's see this in action. To see this, we need to open the console window, as we see, and these are the toggles to enable, disable. This is for general log. This is for warning. This is for error. And this is for clear logs. This is to collapse all the logs in one place. And this is clear, like every time you uh, hit play, it will clear and things like that. So, general console thing. Let's hit play and see. Sorry, it was on maximize on play. Let me reduce it. Okay, so this maximize on play, what it does, it will, as soon as you hit on play, it will maximize the window so that you can get the whole game view. Okay, let's disable this and see this one. So as soon as you call, first thing called is start is called, and then you see every time it is like it's increasing. In every second, it is calling so much time that it's called like 700 plus times now. As soon as you hit pause button, it stopped. The execution of everything in Unity stopped. You want to stop the execution, you just need to hit this part. Okay, I hope this part is clear, like how to attach script, how to create a script, right? Now let's see how to add some functionality to the part. So as I said, everything in Unity has a basic components called transform. So what we need to rotate is programmatically what we need to do is we need to rotate its x-axis, its y-axis, okay, like this every second so that it will smoothly we can visualize it. Okay, so for making it every frame, what we need to write the code in update function. So what we will do it, we will take its transform value. By clicking on transform, it will take the that component's transform, the transform attached to this game object. You can see here. It will take the transform attached to this game object. So I attach the script on this chair, so it will take this transform only. Okay. So what we need to do is transform dot click rotate. Okay. What we want to rotate, what should be the axis? The axis should be vector 3 dot up, like it's the y axis, the up axis, and then at what scale, like if it's what should be the space of the rotation, like it should rotate on its own axis or the world axis. So we just write to space. So you will see the documentation as well. If you are getting confused, like what this thing it takes, you can just see the live documentation as well. So what we are doing is we are rotating with this axis with respect to its own pivot point, axis point. Okay, let's see what is happening. Let's hit play. As you can see, it is moving on its own axis with like the y-axis is moving. Okay, this is how you can interact and use scripting. This is a very basic example. You obviously you can do more complex thing based on your requirement, but this is a example how you can use scripts in your in Unity and attach them. Okay, now the thing is sometimes generally your functions basically run end to end, right? It does not have a like it generally run from start to finish. It does not wait for something or things like that, which we generally have for functions everywhere, right? But sometimes we really need to wait for something before executing the rest of the part. Sometimes like sometimes we need to download. If we are downloading something, if we are downloading an image, then we need to wait for that image to download, and then we can go proceed to draw other things, right? For that purposes, there is a concept called coroutines in Unity. Coroutines basically we have in the mono behavior class. If we don't have this class, we can't have mono behaviors. Coroutines. So coroutines, what coroutine does, it is capable of waiting. Like it can wait and time its process, as well as pausing it entirely. Like for example, if sometimes we need like the color should fade in 1 second, so it after every frame it needs to wait for a setting. Otherwise it will just uh, every frame we need to wait for the other execution. Otherwise it will just directly changes the color, right? So for that purposes we need coroutines. To simply create a coroutine, we just it's just like creating a method, but a different syntax. So let's understand this thing. Let me just remove this prefab and add simple 2D object. Let's see 2D now. Now let's create a sprite. Sprite is basically an image that we have, a 3D image. I think the size is really low, so let's increase the size 10, 10, 10. Okay, there's no image attached, that's why it's something. Yeah, it's coming now. You can just drag any image here. I don't have any image right now, so you can, or you there's a button after it, so you can just click on that and you can just directly choose your sprite. Okay, let's call this anything, whatever. Let's call this sprite only. Okay, now we have this image. What we want to do is after every 2 seconds, maybe, let's change its color. Okay, and we'll see one other class called random class. Okay, the objective is let's create a one other color changer script, and its objective is to change its color to any random color after each 2 seconds. Like it should wait for 2 seconds and it will again come back. Okay, same thing. We create a C# script called color changer. Wait for it to compile. Double click on that. Yeah. So as I told, like every default script, we have this start and update functions. We don't really need to work on that. So let's create a coroutine. For coroutine, what we need to do is we create a iEnumerator type or return type of a function. Let's create a iRoutine and name is change color. Okay, and it's like function only. Now it's showing us a black color because it wants a return statement. What it will return? It will return a iEnumerator type, right? So let's make it a infinite loop and let it run the entire life cycle. And here, let's okay. Now what we need to what we should have in order to change the color, we should have the sprite, right? And yeah, we should basically have the sprite to change the color. So what we can do is let's remove it for now. To take the inputs from the editor, what there's two ways. First, you can declare the variable as public and see public, and that component name. The component name here is sprite renderer. Okay, then let's go back. Sprite renderer, and the name of your variable. Let's call it sprite renderer. Okay, small sprite renderer. Okay, let's save it and see what is there. Okay, it's compiled. Let's drag it to our component. And you will see there is a field in our script to take the input. Sprite renderer. We need to provide it an input. Okay. If we change it to private, we will not be able to see that. It will be gone. Let's see it's compile. It's gone. We need to have it public. Or if we want to have it private only, we can have a attribute that Unity provides. With the help of these square brackets, we can serialize field. Okay, we can use a serialize field so that a private variable we can see in the editor. Now you can see it, right? So that's how you can drag the like take the inputs from the Unity. Now we have the sprite render. What we need to do is we need to change the sprite renders what dot color. Okay, as you know, the sprite render has a property color, so we can just directly change it. Sprite render dot color what okay, so let's do one thing. Okay, so we will have it sprite render dot color. If the color is we said color dot red. Okay, so if the color is red, then it should change the color to blue, or it will just if any other color is already applied, then change the color to red. Sorry, yeah. Okay, so what it does is it will check the sprite color. If it's red, already red, then it will change it to blue. Otherwise, it will change it to red. Okay, so simple piece of code, but it will now running in everywhere. Now we need to stop it. We need to stop. We need to call it by every 2 seconds. So we need to return from here or new, wait for seconds, and wait for seconds. So what it doing it will return this yield return to basically break the execution of this function, and it will return it will wait for 2 seconds, and it will return the execution till here after 2 seconds. After every 2 seconds it will come here, it will change the color and will wait here and then again do it. Okay, that is how we can use coroutines. Now how to call this function? It is not being called yet. It doesn't matter if it's there or not. So let's call it at the start of our program. So as we know, as soon as we hit this thing, we will just go back the start method will call, right? So as soon as we hit it, this change color should be called. To call the coroutine, what we need to do is we just need to use this command called start coroutine. Start coroutine, and just we need to pass the name of that coroutine. Name is change color, and with the brackets, and then so start coroutine will take a coroutine function which you provide, and that's it. That's how you call a coroutine. And at the start also, let's change the sprite color to red. Okay. So that now what it do is at the start it will change the color is red, then it will come here and it will see the color is already red. It will change to blue. It will wait for 2 seconds, and after 2 seconds it will again check if the color is red. No, it's not. Then it's again it was blue, so it will change it to red. Let's see this script in action. Okay, it doesn't work. Why? Because we have an error. You can see if we are getting error going into console and it says unassigned reference exception. The variable sprite renderer of color change has not been assigned. So it's not been assigned here. We need to assign it. We need to drag and drop. So, okay, why are we dragging drop this, not this? It's the same thing. You can drop this as well, but you can also drop this because it has the sprite render component. So it will automatically search for the first sprite renderer component from this game object. Okay, let's now play this. Now you see, change to blue. After 2 seconds, change to red. Again blue, again red. Okay, now let's change it to after every 2 seconds. Let's not only from red to blue. Let's change it to any random color. Okay, let's remove this part and also this. So we have one class called random dot range. From range we have float and int. For colors we generally use random dot color HSV. So it will take the HSV values and it will generate any random color. Okay, so these are some of the classes, some of the important classes that we have in Unity. One is random, which is basically provides you with easy ways to generating various commonly required types of random values like color, integers, many other things. Then we when we saw the game object has transform, they have name, they have you can get the component. Yeah, okay, I'll tell you one more thing. Okay, let's remove this. Okay, now what we have is we don't, it's not saved. Okay, error is coming, that's why. Okay, remove the whole part. Sorry, let's remove it, the serialized part. We will not take the input from Unity. Why to take the input if we know that the script is attached to the same object in which the sprite render is there. Why do we need to drag and drop, right? So we can just directly take it. How? We can just go and take the game object dot, we have a function called get component. So it will get the component of type sprite renderer from the same game object. So game object provides these kind of methods or APIs to get it, and we will get the component and assign it to sprite renderer. Now it will have the sprite render which is attached to the same game object. Okay. Now if we go back and hit play, you will see that after 2 seconds it changes to a random color. You can also see the color property is also changing, right? Okay, that is the coroutine. Yeah, other important classes have mono behavior, which basically has like the base class of every Unity script. And we have object class. Object class is the base class of all the objects that we have, including game objects. And we have transform, where we have access to position, rotation, and scale, and many other things related to the object hierarchy and positioning, things like that. Then we have vectors. I think in last one we didn't use it. Okay. So where we can manipulate 2D, 3D, and lines and directions, these things. Then for rotation, we have quaternions and things like that. Time, math class. For different purposes, Unity provides basically internally classes. Let's have a check on time. We have we only have 15 minutes left. Okay, so let's move on to a different topic we have called colliders and Unity physics. Sometimes what you want is, for example, if you are you need to use the concept of physics in games, right? For example, if you are shooting something from your gun, it should hit someone, and something should like the ball should act something to that enemy, right? The enemy should fall, or it should die, or whatever. But how will you know? How will a ball know that it interacts with that enemy? That, and what is to be done when we like if the ball hits, it should drag, it should throw away the enemy, or things like that, right? For that purposes, Unity provides certain APIs or by default components called the two major components that we use is colliders and rigid bodies. Okay, so colliders basically components define the shape of a game object. Let me show you. Let's see, this is a game object. By default, Unity attach a collider. This is a box collider. You will see, you will see the green color edges. Yeah, can you see it? The green color dots. That's the edge of like that defines the shape. It is not mandatory that like we can modify it by using this thing, like the tools that we have, the center and the size and everything we can modify, but by default it will stick to your actual size. Okay, this will define the boundary of your object, that hey, this is my shape, because a ball does not know the shape of an enemy, right? So we need to manually define the shape of that particular thing that we want to collide with. So like in actual view, like in game view, you can't see the collider. It's invisible, but it will behind the scenes it is doing its job. It is not it's not visible to the user, but behind the scenes, it is actually working all the calculations and everything. Okay, so this is, but what is to be done after we collide? Like, uh, like there should be a force, or there should be a velocity, there should be a drag, there should be gravity. Like if you see many games, like if you throw something from a top, it should the gravity should act, right? So that is being taken care by a rigid body. Okay, a rigid body component is basically is the core of the unity physics. So it takes mass. What is the mass of the object? It may be different for every object. Like the same gravity behave with the half of mass, right? So it has angular drag. It is by default it uses the gravity. You can manipulate all of this. Okay. So now if I hit play, the gravity will play its role. See, it dropped down. Right. See that, right? Now, if I create a platform, let me shift this cube to a part, and let's create a platform kind of thing where we can see it falling. Okay, so if as soon as we create a any 3D object or something, the box collider will be attached to it, and it will stick. It depicts the shape of this object, and now this cube will start falling because there is no because the rigid body is applied on this cube, and it will start falling towards the downwards. But this this platform has a box collider that depicts the shape, so that this cube will understand that there is some obstacle I should stop. There is a floor kind of thing. So let's see in action. Yeah, it will just stick. Okay, if I remove this just for fun, it will just fall again because now there's no platform. Now there's no floor, so there definitely I'll fall, right? So it's the same concept. So these two things are used. Rigid body is the core of the physics. It has, if we apply rigid body over that, it understands the physics of that object, and the collider will help understand the shape of that object, and it will have all the, like, in which to which object I collided with. It has all that information. I am attached to which object. I collided with which object. What is my position? What is my size? What is my shape? All of this thing is taken care by box collider. I hope you got get it right. Okay. Now, one more thing I want to cover here is Unity UI, which is definitely a very major UI plays a very major role when we make our application, right? So let's see how can we create like very good UIs for our application. Okay. Now, Unity UI has basically a different system. So if we want to create a UI, we need to create a canvas first. So canvas is basically, you can say, what you call the thing, where you draw all your paintings, right? I completely forget. What do we say this? Like a frame kind of thing where you draw all your paintings, right? It is your like art board. Yes, it is your art board where all your art is being drawn. So the main core part, every UI element that you attach should have a canvas component as a parent. So if we create a canvas here, what we see is, First of all, it will create a imaginary rectangle. Okay, that my canvas is this much size and all. So by default, you will see one difference. There's no transform, but there is other thing is a rect transform. We can remove everything, but we can't remove this. It will say can't remove component because canvas depends on it. We can remove everything, but not the transform of it. And why is it changed from transform to rect transform? Because transform is basically for 3D things, like it will create imaginary points with the help of your XYZ points on the real world, on the real scale. But rect transform does the same thing, but with the help of an imaginary rectangle instead of a whole uh, the real world axis. It will create a artboard, and then it will have the all the transform values to that imaginary rectangle only. Okay, then we have a canvas. This is the most canvas game object has two major components. First is the canvas. Let's minimize both of them. Canvas is basically render. Sorry, canvas is told you the artboard, and the render mode is the most important thing. It has three modes. First is the screen space overlay. Screen space overlay means everything that you create inside every UI that you create, being any button or image, it will display on the screen, on the screen space, on your actual screen over everything. Okay, screen space camera means it will create a imaginary plane with some distance from your camera to that plane, and everything will render on that plane. Instead of the screen, it will render on the plane. So sometimes we need something like you see when you play this gun kind of game, you see a pointer, right? Or you see a gaze interaction in VR, this thing, right? So what it does, it render a UI at some distance from a camera, and it will follow the camera. If you see here, like if you move your gun, that pointer will remain perpendicular to your camera, right? It will be like this only. So it will, what it does internally, it creates a why important? Because it builds the UI on a 3D space. So you don't want your UI to come, like if you are wearing that Google the cardboard glasses, if you wore them, then if some UI just stick to your eyes, even though you are moving your head and all, some UI is sticking to your eyes, you will feel a bad experience, right? The UI should be in some place sticking to one particular area in a 3D space, right? So if I change it to world space, it will ask you to have a position in X and Y, and with height and width as well, for to manually position it in the 3D world, not in the 2D space, in the 3D space. Okay, so this is screen space, camera space, and world space. Let's talk about overlay space, like screen space only. Here we have anchors as well. So anchors, what is anchors means? Anchors, you can see, anchors are basically these small triangles. Where are they? Okay, I need to add some components. So inside that canvas, let's create a text field. Okay, and say hello all, the text component. We'll see it later. So you see this triangles, right? So these are the anchors. What anchors do is it's basically depicts that your UI should stick from which point. So right now it sticks to the center of this object. For example, if I take this thing and I move it to the right side or to the left side, then what it depicts is for if you change your resolution, if you change your size of it, I I will stick to my right side of it. So if I change the width, so if I change some resolution or something, I will stick to my take all my calculations from my right hand side of my uh, uh, of parent. Okay, these are the anchors. To be precise, it will like minimum from like zero point 0.5 and zero point 0.5 it's the uh, uh, center, like zero point 0.5, zero point 0.5 is the center. It ranges from 0, 0, 0 and 1, 1. Okay. Anchors basically depicts for if you are designing your UI for multiple resolutions. So it tells that your UI should stick to this from this area. If you increase the size, if your icon size changes, that I will stick to this area and rest of my part will shrink or will move. Okay. Other thing is the pivot point of this. So pivot point is basically if I move this pivot point, okay, center. If I move this pivot point to this area, and I have to uh, like okay. If I have to rotate it, it will move from its pivot area, like from the left side. For example, if I move the pivot to its center, it will move from its center point. So the pivot is basically where your point is attached, where your pivot point is. Okay, so if I show one real example of pivot, so that you see my screen, right? So if my pivot basically lies here, so my hand will move like this from the middle. But if my pivot moves here, so my hand will move like this. So that is how pivot works. Then we have some UI elements. This is basically text, image, button, text, slider, scroll bars, drop, some major, some commonly used icons, right? The most common used one is the button. I want to talk something about it. Let's remove this text and talk only about button. Now, as soon as we add a button, it will take like it will take a canvas render. If I don't have a canvas and I create a UI button directly, what it does it will create a canvas. Then only it will work. Okay. Uh, so sorry I didn't cover this part. Let's first cover this part. So in the canvas we have a canvas scaler as well, where you can generally we use scale with screen size to match the screen size, and then So canvas scaler is if in case of some other resolution, how will a canvas scale expand or shrink according to that? So what we do is we generally take a reference resolution that my 16:9, like my laptop screen or my like my phone resolution is my reference, and I will design all my UI from this of this type. And if something some resolution change, that my reference is this. If if I have to change something, I will take this as reference, and then I will change my UI size. Okay, and I will match my screen and width with like half, 50-50%. So this is the canvas scaler, and there's one more important is the graphic raycaster. So the graphic raycaster basically takes your inputs. It used to take your input from this event system. So as soon as you create your canvas, the event system will automatically be created, and it will automatically associate with your graphic raycaster. So as soon as you click on something, on you hover or something on some button, or you do anything like in a slider, if you slide something, if you drop down, if you click on drop down, the list will show. It will be taken care by this event system and the graphic raycaster. It will take your events. Let's talk about buttons now. What we have in buttons. The first thing we have is the rect transform, which we have for all the buttons. Default width is 116/30. Let's increase this 300 by 100. Okay, now we are able to look, right? Then we have an image component where we this image is attached. You can change, like it's like an icon. You can change it to some other icons. Let's change it to maybe background or whatever you want, or you can change the color according to your needs. Based on your choices, you can manipulate it. Then we have a button component, and this button component has some basic button features called interactable. Is it interactable on or not? And some basic transition. This transition is basically you can manipulate it. Transition Unity provides like through this event system, it provides like if you hover over it or if you click on it, what should be the default functionality that it should work, right? If you click on some sprite swap, that for example, if there is a sprite means image, sprite of a boy, and if you want that on clicking on boy, it should the image should change to a hen or something, that you can do it. Okay, you can just swipe and it will take care of it. Right now it's tint, so the thing is like the normal color will be white, like the multiplier of white, and disabled color is gray. So if I disable it, so you can see it will turn to a gray color. Like if I have it white, so you can see it will turn to a gray color. If I change some value like a red color or something, it will show, right? Then we have on click event. This is important. Video does not provide you a default click behavior, but it provides you a placeholder to how to make a click. For example, if you want to click on it, what should happen? So it will happen here. You need to add behaviors in order to make it happening. Okay, so let's make it interactable, and let's first see what is happening if I click on. So if you see, if I hover over that button, the color changes, and I click, it is giving me a feedback that it is clicking. It's not happening anything because we don't have a on click event attached. So let's create one. Okay, let's create a script called what should we do? Let's change the color only, or let's move it. Let's move the sprite. Okay, movement. Or let's change the font. Okay, we by the way, in the button we have a child called text, where we have this by default text written, that is button. You can change it. That let's change it to please click me. Okay, and we can change the font, all of the basic text editing things. We can increase the font size. Let's increase it. Please click me, and let's open the script movement. In this movement, let's create a function called on click. Sorry, private void on click. Okay, and on click one, what we want is, let's take input from editor. Let's take the text. So text, and let's call it button text. So let's change the button text to let's change the text property of that button text to let's say clicked. Okay, now on clicking it, the button text should change the text to clicked. It's a very simple script, the basic behavior. We can do it like more complex things based on your choice. Now we need to drag our script here. Sorry, we need to drag our object here, not the script. We can't just directly drag it here. You can drag it, but it will not work if I change like it will not work. It will throw errors. So if for that I need to create a object, or I can attach the script anywhere. Let's not create it. Let's attach the same script to this canvas and whatever. Let's create the movement script and drag the text to this one. Okay. Now what we need to do is the object. Where is my movement script? In the canvas. We need to canvas, and in this canvas, it will list all the functions that it has. So it will have all the components that is attached to that canvas object. We have the game object, we have the rect transform, we have the canvas scalar, graphic cluster, and then we recently added movement. Now you see here, we have different functions and public APIs. Public variables that we have, but we are not seeing our on click event. That is why, because we made our method private, we need to make it public to make it visible to the editor, make it visible to the movement script. So if I again go back to movement, now we see the on click. If you click on click, now it registers. Now see what is happening. So if we click on that, the button text change to click. That's how we can do multiple things we can achieve by adding on click listeners and things like that. So that is all about basics of Unity UI. Basically, we can add multiple things, like we can make it more complex, but these are the basic of that Unity, like multiple uh, uh, things like UI, physics, transforms, scripting, coroutines that we covered today. I wanted to make a game with you all, but due to time constraint, we cannot do that. And yes, one more thing, the 3D assets and textures. Let's quickly cover this because you might need it when you work on the AR/VR application. So for example, it will be same as okay, let's create a sphere. So what we have here is a mesh filter. So if we create a 3D object, if you import any 3D object, you will find these two components as mandatory. Three basically shaders. So one is your mesh filter, which is basically what to draw, which mesh to draw. And then we have a mesh renderer, which is basically how to draw, how this mesh will be drawn in front of the camera. Will it receive shadows? Will it cast shadows? What are the different settings? Which material should it have? So by default, Unity attaches a default material to it. Material is basically of which type of which material does it 3D mesh has. We can create our own material as well. We can just directly right click here and create a simple. Let's call it a red chair, for example. Yeah. Let's click on that one. And then we have a color property. We have a standard shader by default applied, and which has a albedo, basically a color of white. Let's change it to red. Okay, and we have our chair prefab, right? Somewhere. Yeah, this is our chair. So here also you have it. Let's disable this one. Here we have all of this this default material, right? We can just directly change the material, and you will see it will change it the real time. So by selecting all of the meshes, and we go here and we drag this material to the material part, and it will change it. Sorry, to the base as well. It will change it. Right. This is how, like on the material, we change the properties by creating new materials, and the materials have shaders. By changing the shader, we can achieve multiple things. These are the advanced topics. We don't need to cover into that. But mesh receives material. Material uses shader to draw the screen on the screen. Right. Similarly, if we want to create a yellow chair, we can create a new material called yellow. Change the color to the yellow, and just sorry, change the whole part to yellow. This is how you create multiple instances of that. So yeah, let's move on to our original thing, that we understand the game objects, we understand how transform works, how components, what are the components, different components, how we attach user-defined components, and we understand tags. Then we get to know about parent objecting, parent-child relationship, how they connect with each other. And we had a discussion about prefabs, what are prefabs, how we create them, instances, nested, variants. Then we have scripting. We wrote around 3 scripts, like how to create, how to link a script, how to rotate, what are the coroutines, how to, we forgot to, how to launch prefab at runtime. It's very, very simple. What you just need to do is, it's just a simple command called instantiate and your prefab name. Right, you can just take the input from Unity called game object and called chair, and on that click you can just directly the chair. You can see this in action. Let's remove both the chairs, enable our canvas, and see. Oh, sorry, we didn't drag our chair component. Let's drag the chair component. Now, as soon as we click on this button, chair should appear. See, Prefab, a game object, is basically generated at the runtime. Okay. Then we have logs, and we have physics, inversion over UI, then the 3D assets. That's it. This session. If you have any questions, please feel free to ask.
Thank you, sir. Participants, if you have any queries, please unmute and interact with this person.
Sir, it's just like Java or Java programming like that, sir.
It's C sharp basically. So it has all the features of C sharp.
Okay.
Basically, C sharp and Java kind of similar, like both of like most of the things. But
Okay.
yeah, it takes C sharp script as it.
Sir, in order to work with the Unity 3D, whether we have some previous experience with C sharp, or just like that we start to work with Unity 3D without knowing.
When you install the Unity, it will automatically takes all the .NET frameworks that it needs, and you just need to create a C sharp script as we did in the demonstration. We just need to create a C sharp script. It will take care of it.
Okay, so just we should have some basic knowledge in OOPS concept, C sharp,
Yes.
or yeah,
Yes.
Java like that.
Yes. We should have some programming experience.
Experience.
Basic one, but yes, we should have it.
Any other queries from the participants?
So this is Matan again. How about the texturing part? You showed me like applying color. Okay, through Albedo, we can apply some images that we can brought here. But how about the materials? Like for example, if I'm working in some software called Maya, so we have a different shaders. So is it possible to bring the similar shaders, similar effect over here?
Yes, as soon as you import your assets, 3D assets, it will import all of the, like in case of FBX file, if you export from your Maya, it will take like all the textures that you applied, all the UV maps, everything that you have, like the same model you can visualize in Unity. It will automatically take care link and everything in Unity. You don't need to manually like do it or configure anything.
Yeah, but the thing is, sometimes if I'm applying only colors, like in some places the shaders will be only with colors, some parts. So at that time, it got like I got some issues over there. If I'm working with UV, then everything will everything gonna transfer, all the UV maps and everything gonna be easily mapped automatically. But if I'm working something with a blend material or some other materials. So that particular thing is kind of a even though I can see blend, but I can't able to apply it. Like I can't see that in the final out.
Maybe it also depends on the lighting, like the scenes infrastructure that you have. Like basically, you in Unity you can't have the almost the same effect that is in Maya. Even in like the artist need to import it and then apply some post processing and also some lighting and shading over Unity's shaders. Some of the shaders are not compatible with each other. Like as I saw, Unity says it does, but as per my experience, I didn't. I got to know that it's not. We need to work on some part. Like we need to work on some shaders in Unity as well. So I agree with you. Like it sometimes it like for some shaders, for some particular parts, it does like we need to rework on it. But most of the cases, we don't have to.
Yeah, thank you, man. Thank you very much.
Any other queries from participants?
If not, I can come again. Madan here. So, how about like in VR, we have to like if I'm creating a 3D environment, so I have to move towards that particular thing or interacting towards that particular thing. So I have to write coding for like okay, here you have to write code for everything. Like for example, if I want to move, you have to write code, right? Am I right?
Yes. Not everything, like if you have to do
Yeah.
some basic things like disabling, enabling game objects and all, you can just directly drag and drop and use use the inbuilt classes uh, uh, like game object and set active to true and false. The basic thing that you can do, but for the complex things, yes, you have to write code for that.
All right. So how about that HMD, like HMD devices like a Vive or a Oculus? So we have to write coding for interaction purpose. Like if you are going to do some interaction thing, you have to do uh, different coding setup.
So these all of these companies provide SDKs for that. So we don't have to reinvent the wheel to make it like to interact with all the 3D objects. These like for in case of you said Steam VR, right? HTC Vive. So HTC Vive Steam VR already being taking takes care of these interaction types. uh, but they also used coding to make it work. So yes, for these complex things, yes, you need to code. But for the current like if you talk about VR HMDs, all the SDKs have provide SDKs to uh, interact like to for basic things like interaction and rendering and everything that dual eye support, everything they just take care of it. We don't need to reinvent the wheel basically.
But the movement part, like if you want to go further, or you like you have to like the tracking positions. So I'm talking about that, like tracking things. Is it fine, or like you have to
uh,
write coding for like a particular company will give you that, or you have to do the coding part?
No, all the SDK covers the tracking, your movement, the slam thing. If you talk about your positional movement, that Oculus have the sensors, right? So they will connect with the hardware, track you, and you just need to do the other part. Like what should happen if I interact with this? That is yours. Interaction, movement, tracking, all of these are being taken care of with the SDK. You don't need to write anything.
All right. Thank you very much. Thank you very much, man.
Yeah, if you have any more concerns, you can just like this is my email address akshay.arora@thoughtworks.com, and also my LinkedIn is Akshay Arora. So you can just directly ping me there, and we'll have a talk there.
Sure, man. Sure. Thank you very much for sharing your ID. So if there is any queries, just I can post you there, right?
Yes, yes.
Thanks.
Yeah.
Thanks a lot.
Thank you so much. Thank you so much, participants, for joining again. I hope.
Thank you. The session was highly informative and useful. I hope this will be an eye-opener for our participants to do more innovative works in Unity. I also request the participants to explore more on this. It is a pleasure to have you as a guest. I extend my heartfelt thanks to our resource person on behalf of our management and Department of Computer Science and Engineering. Thank you so much, sir.
Thank you so much, ma'am, for having me here.
Thank you, sir. I thank all the participants for your active participation. And I request the participants to join tomorrow's session sharp at 10 a.m. in the same link. Attendance for today's session has been posted in the chat window. The session comes to a formal